Hi, in this video we're going to consider a sphere rolling down a ramp. And what I want you to do is to compare two methods of determining the rotational kinetic energy of the sphere. The first method is based on the idea that the sum of the rotational kinetic energy and translational kinetic energy as the sphere rolls down the ramp is equal to the gravitational potential energy it has when it's stationary at the top of the ramp. The second method involves calculating the rotational inertia based on the shape and mass distribution of the sphere, and then using this to work out the rotational kinetic energy. Now, to do that, you'll need to convert the translational velocity into angular velocity. The sphere has a mass of 3 kilograms and a diameter of 9.5 centimeters. The height at the start of the ramp is 19.6 centimeters. And at the point that I recommend considering the sphere having rolled down to is the midpoint on the ramp, the 50 centimeter mark, and that has a height of 11.5 centimeters. I would calculate the average velocity between the 40 and 60 centimeter mark down the ramp, and then use that velocity as the actual velocity of the sphere at the 50 centimeter mark. The video was filmed at 200 frames per second. Okay, let's see how you get on. Alright, so the questions I want you to answer now are: what are the values for the rotational kinetic energy of the sphere by each method? Then, how can we account for any discrepancy between the two values? And a bit of a conceptual one here. What effect would a slight decrease in time between the 40 and 60 centimeter mark have on our calculations for rotational kinetic energy? And if you cope okay with that, I've got a challenge for you. And the challenge is, in the video, the sphere covered 20 centimeters in 38 frames at 200 frames per second. If the sphere covered the same distance in fewer frames, at what number of frames would the resulting answers for rotational kinetic energy break the laws of physics? All right, have fun.